Hi, welcome everyone. Welcome to reInvent. I'm excited to be here with you. My name is Charlie Deitch. I'm the Director of Energy and Water Infrastructure at AWS. I'm going to be joined today by my colleague Cornelia, who is our community engagement teams. And if you're here in the audience today for this session, it's because you care deeply about sustainability. You might even be directly responsible or accountable for your organization's sustainability goals or your organization's carbon footprint. And because so many of our customers trust AWS to run their critical workloads, it means that for a lot of our customers, their carbon footprint and sustainability impact flows through AWS. We take that really seriously, and today I want to talk to you about what we're doing to reduce our carbon footprint, and Cornelia is going to talk about what we're doing to engage the communities where we work with. So let me cover our agenda quickly here. I want to start by talking about AWS's global infrastructure. So what does the cloud actually look like in the real world? I'm going to touch on the climate pledge, which is Amazon's commitment to get to net zero carbon emissions. And then I'm going to talk about how we're getting there, which really comes from using our resources more efficiently, leveraging our renewable energy portfolio to decarbonize our electricity supply, and some of the work we're doing to remove carbon in our supply chain. And Cornelia is going to talk about community engagement work at AWS. Okay, so this is what the cloud looks like in the physical world. AWS infrastructure is spread across 96 availability zones in 30 geographic regions around the world. And we've announced plans for 5 more new regions in Australia, Canada, Israel, New Zealand, and Thailand. Now, each region is a physical location in the world where we have multiple availability zones. And each availability zone consists of at least one data center. Our availability zones are discrete places with redundant power networking connectivity, and our data centers are housed in separate facilities. Okay, so when we talk about sustainability at Amazon, we really start with the climate pledge. Amazon co-founded the climate pledge with Global Optimism in 2019 to build a cross-sector community of companies and individuals and partners all working together to address the climate crisis. The climate pledge is a commitment to reach net zero carbon emissions by 2040, which is 10 years ahead of the Paris Agreement. So why 2040? Well, the science tells us that we have a limited window to make unprecedented headway in mitigating global emissions to keep warming below 1.5 degrees Celsius. We know that no one company can do this alone, and organizations don't exist in a vacuum. So to drive collective cross-sector action, we co-founded the climate pledge. We have conviction that businesses are responsible, accountable, but most importantly, that businesses are able to act to address the climate crisis. So when companies commit to the climate pledge, they commit to 3 things. So the first is regular reporting, which involves accounting for all of the emissions across your business, tracking those emissions, and then sharing them with your stakeholders, your customers, investors, employees. The second part is about eliminating your carbon footprint. At AWS, we're doing this by leveraging our renewable energy portfolio, and I'll talk about that a little bit later today. The third part of the commitment is to neutralize any remaining emissions using credible carbon offsets by 2040. We know that reducing global emissions is going to be the challenge of our generation, and it's going to require how companies, governments, and the public all work together across the economy. That's why we co-founded the Climate Pledge, and we launched the Climate Pledge Fund. We've had over 375 organizations from around the world sign up to the Climate Pledge, and they span 34 countries and 54 industries. And it's really important because these companies come from all sorts of different sectors across the economy, including logistics, financial technology, and consumer goods. Okay, so the Climate Pledge is kind of our North Star. That's where we're going when we think about sustainability at AWS and Amazon. But how are we getting there? And the first part really starts with energy efficiency. It's closely linked to operational efficiency, which has been in the DNA of AWS infrastructure from the start. We think about energy efficiency, we think about using the resources we have as efficiently as possible. And we think about it up and down our technology stack. So all the way from the physical buildings where our data centers operate, down to the chip level. So let's start there at the chip level, which is one of the most visible ways we're innovating to increase the power efficiency at AWS. AWS's global infrastructure is built on our own custom hardware. We have purpose-built servers, routers, and processors, all custom designed to run workloads by AWS customers. And one example how we're designing that equipment with sustainability in mind is our new Graviton 3 processors, which is our third generation ARM-based EC2 instances. In addition to providing better cost performance for customers, our Graviton 3 chips also provide the same computing resources for 60% less electricity. So think about that for a moment. We can reduce our electric consumption by 60% just by upgrading our hardware. And we're working hard to upgrade EC2 and services that run on EC2 to be running on the Graviton 3 chips. But we're not stopping there. We're also looking ahead. We know that increasingly workloads from customers are in machine learning and AI. And our new Inferentia chips are our most power-efficient machine learning chips. And we're working to roll those out across our global infrastructure. So from the chip level all the way up to the large physical buildings, the data centers where we operate, we're continuing to design our infrastructure with sustainability in mind. On our most recent generation of designs for our data centers, we use techniques like computational fluid dynamics to model the data centers during the design phase to make sure they operate efficiently as possible. What we did is we created numerical models of the data center in the cloud, and we're able to quickly change design parameters, fan speeds, set points, to figure out which design is the most efficient. We can track how air moves through the data center. We can track the air's temperature, velocity, humidity, all trying to figure out what layouts and configurations are the most energy efficient. And this led to a design where we reduced our cooling load by 20% across our data centers. And we're working to roll out this infrastructure across Oregon, Virginia, Ireland, and all around the world. But once you design your data centers, you have to put them into operations. And if your organizations are anything like AWS, you love data. And you love tracking data and iterating to make sure that your performance is meeting your benchmarks. And that's exactly what we're doing with our data centers. Here you see a plot of several days where we have our expected data center load, how much power we think they should be consuming, versus the actual data center power consumption. And in order to create that curve, which is our expected consumption, we created models using AWS services like S3, Lambda, Athena, and Redshift. And we pull in weather data sets from places like the Amazon Sustainability Data Initiative. And we use these models to predict how much the data center should be consuming power based on the conditions that are happening outside. We look for deviations, and we meet with our operations and engineering teams weekly to root cause those deviations and address any issues. It creates this really quick feedback loop where we can continue to iterate and make sure our buildings are operating as efficiently as possible. Okay, so we've gotten pretty good at operating our infrastructure efficiently over AWS's operating history, but what does that mean for our customers? Well, studies by 451 Research have found that the AWS cloud is 3.6 times more energy efficient when you compare it with on-premise data centers in the United States. And it's 5 times more energy efficient when you compare it with on-premise data centers in Europe and APAC. We also found that by migrating to the cloud, customers can reduce their carbon footprint by 80%. And we expect that number to grow to 96% as we reach 100% renewable across our portfolio. So how are we able to achieve these efficiencies? Well, a big part of it is the initiatives I just talked about, constantly iterating on our designs of our hardware and our data centers. But another part of the story is scale. So just like economies of scale help with better cost performance, it also helps with energy efficiency. And utilization as well. We're able to run our infrastructure at higher utilization rates because we have a larger scale, but also because we can dynamically load balance customer loads across our servers and racks. In addition to being laser focused on energy efficiency, we also obsess over how much water we use and ensuring that water is sustainable. I'm really excited because earlier this week, we announced our water positive goal. Our water positive goal is a commitment to return more water to the communities where we operate by 2030 than we use in our direct operations. We're going to meet this goal by further improving our water efficiency and increasing the use of sustainable water sources in our data centers. We've got a lot of work to do, but we've already made some really good progress on our water sustainability program. We've converted 20 data centers to recycled water, which leaves more potable drinking water for the communities we operate in. We have an industry-leading 0.25 liters per kilowatt hour, which is a measure of how effectively and efficiently we use water for cooling. In our US West Oregon region, we're recycling nearly all of the water our data centers consume to the agricultural community. So instead of discharging data center cooling water into the sewage system, which is what you typically see at a data center, we take that water and we discharge it into the irrigation canals, and the farmers that operate around the data centers then use that water for irrigation. And finally, our water replenishment efforts that we've completed or are in progress will add more than 2.4 billion liters per year to the communities where we operate. We've actually been focused on water sustainability and a water positive goal internally for a number of years, and I'm really excited to make it public this week so we can share our progress with our customers. Okay, so we talked about how we're using less through energy efficiency and water efficiency measures, but we know that our data centers are going to continue to use electricity, and we want to make sure that electricity is sustainable and carbon-free. And when we announced the climate pledge, we knew that there are areas we could move really quickly to decarbonize our business, and renewable energy was one of them. So I want to talk to you a little bit about what that growth story looks like. I'm coming up, this week is actually 7 years at AWS, so I got to see this portfolio grow over time. And before 2020, before we announced the climate pledge, we had announced about 1,000 megawatts of renewable projects. And for those that aren't familiar, 1,000 megawatts is a significant amount of renewable energy. It's maybe 5 to 7 of those really big wind and solar projects that you'd see if you were driving around the rural landscape. But in 2020, after we announced the climate pledge, we increased that portfolio by 6.5 times in just 1 year. We grew our portfolio to 6,500 megawatts, and that's enough renewable energy to power a large mega city like Washington, D.C. 2 times over. But we didn't stop there. In 2021, we nearly doubled our renewable portfolio again, and we brought it up to 12,000 megawatts of renewable energy. At 12,000 megawatts, you're generating enough renewable energy to power a state the size of Nevada. You think about that for a moment. That's Nevada, Las Vegas, the Strip, reInvent every year in all of our laptops, all of these presentations. And at 12,000 megawatts, we're managing a renewable portfolio that's the size as some of the biggest utilities in the world. Our demand is having a meaningful impact on supply chains. So we see solar manufacturers and wind turbine manufacturers scaling up and ramping up to serve Amazon and other corporate customers with renewable energy goals. We also start to see a bit of an operational burden in managing our renewable energy portfolio. I'm going to talk about that in a minute here. And finally, in 2022, we had our biggest year ever. We announced another 7,000 megawatts of renewable energy projects around the world. And at 19,000 megawatts of capacity, when our projects are online, they're going to generate enough renewable energy to power a country the size of Switzerland. And I'm proud to say that today, Amazon is still the largest corporate buyer of renewable energy in the world. We have over 380 wind and solar projects around the world. Now, 160 of those projects are the really big wind and solar projects that you'd see, like this wind farm here in Tehachapi, California. The remaining projects are rooftop installations at our fulfillment centers and Whole Foods markets. In total, our renewable energy portfolio will produce enough electricity to power 4.8 million US homes, and that's 50,000 gigawatt hours a year. And last year in 2021, Amazon powered its businesses with 85% renewable, and we're on track to improve on that this year and on a path to get to 100% renewable energy by 2025. One of the things that I'm really excited about is that increasingly our renewable projects are found all around the world. Now, when we first started scaling our renewable energy portfolio, we focused a lot in the United States and Europe. And that made sense for 2 reasons. First, AWS has a large presence in both the US and Europe, but also those are places with mature renewable energy markets and industries. And we were able to move fast at a pretty big scale. But increasingly, we're focused on new countries around the world. This year, we announced our first projects in India and Brazil. We also had our first projects become operational in Canada, the United Kingdom, and Singapore. And enabling projects in places like India and Brazil are important for 2 reasons. So the first is economic development benefits. These projects have an outsized impacts on the economies where we develop them, and in some of these countries like South Africa, we're leading to help create a renewable energy industry. And the other reason is because of the carbon impacts. Particularly in India, this is true. So in India, the electricity grid accounts for, or coal on the electricity grid accounts for 78% of the electric generating mix. Because of that, the carbon intensity of the power grid there is higher than the global average. And we know that our projects can have an outsized impact on abating carbon in places like India. And in 2022, we went really big. We announced our first 3 projects in India for a total of 420 megawatts. Those renewable projects will help us power our region in Mumbai and our newly launched region in Hyderabad with 100% renewable energy. Combined, these projects will generate over 1 million megawatt hours a year of clean power, and that's enough to power 360,000 typical homes in New Delhi. One of our projects in Rajasthan is the largest solar project ever enabled by a tech company in India. It's also Amazon's biggest solar project in all of APAC. But because we're so excited about India and because we can make such a big impact, we're actually announcing 2 additional projects this week at reInvent. Both of these projects are hybrid wind and solar projects, which is really exciting. It's the first hybrid wind-solar combined projects that Amazon has in our portfolio. And the reason to combine wind and solar is because they have a complementary generation profile. So if you think about solar, ramps up in the morning, peaks about solar noon, and comes down in the afternoon. Wind ramps up in the late afternoon and stays steady overnight. So because these 2 daily generation profiles complement one another, we can put more clean energy on the grid in these projects and have an outsized impact on removing carbon. 2022 was the biggest year for our new projects coming online in Amazon's portfolio. We had over 2 gigawatts of projects come online in Singapore, the United Kingdom, and this project here, Traverse Solar in Canada. Traverse Solar is actually the largest solar project in the province of Alberta. And for AWS customers, you're used to being able to provision large amounts of infrastructure, large amounts of compute in the cloud in a very short period of time. Unfortunately, that's not the way the renewable energy industry works. It takes 2 to 3 years to develop a project like this, Traverse Solar. It starts with Amazon going out and talking to developers and looking for projects that have the characteristics that we're interested in. Are they in the same grids where our data center operate? Do they meet certain financial criteria? Do the developers have a positive relationship with the community where they're building these projects? Amazon then commits to these projects by agreeing to buy all of the renewable electricity over a really long period of time. That allows the developer to go out and get financing, procure turbines or panels, and actually construct the project. And that's a 2 to 3 year process. We began speaking with the developers at Traverse in early 2020. Really excited about this project. I mentioned it's the largest in the province of Alberta. It's also going to allow us to power our new region in Calgary with 100% renewable energy. And you might be thinking, are you guys sure about doing solar in Canada? Does that really make sense? Well, it's true that a project like Traverse would generate more renewable electricity at a more southern latitude, like Southern California. But the other component we have to think about is what is the carbon mix on the existing grid? And the carbon intensity of the grid in Alberta is 65% more carbon intense than the grid in Southern California. So we actually have an outsized impact in reducing global carbon emissions by locating this project in Canada. We also had our first renewable project come online in Singapore, which is really exciting. Singapore is a really important market for AWS and APAC, but it's a really hard place to bring new renewable energy projects online because of the lack of available land. This project uses a ground-mounted tracking system, so the solar panels actually track the sun as it moves across the sky throughout the day. That's a pretty common technology in other parts of the world, but it's not so common in Singapore, where most of the solar panels are found on rooftops. This is actually the largest ground-mounted tracking solar project in the whole country of Singapore. And of course, our renewable portfolio is a means to an end, and that end is reducing carbon emissions. Increasing the production from our renewable portfolio is critical to meeting our goals under the Amazon's climate pledge. Every megawatt hour we can produce avoids a megawatt hour of fossil fuel being put on the grid. And in total, our renewable portfolio, when all of our projects are operational, it'll avoid 19 million metric tons of carbon every year. And to put that number into context, 19 million metric tons of carbon is the amount of carbon sequestered in a forest the size of Portugal. So you think about the forest the size of the country of Portugal, that amount of carbon is being avoided from putting into the atmosphere every year by Amazon's renewable portfolio. Okay, so we built this really big renewable portfolio, and now we have to figure out how are we going to manage it. And every organization that gets serious about tackling sustainability is going to face this challenge with sustainability data. And when we were scaling up our renewable program, we had a few ways to tackle this problem. Now, the first is to keep it surface level, manage performance using spend as proxy. And frankly, that's what we did before 2019. We would look at our monthly invoices, look at how much power they generated, and that allows us to track a baseline of how we're performing. We can't do any optimization, and we can't improve. Utilities and energy companies that have been running power plants for 100 years, they operate performance by hiring teams of analysts to look over hourly data of the plants. And that works if you have a couple projects in your portfolio, but it doesn't work if you have 160 utility-scale renewable projects around the world. So what we did was build scalable software in the AWS cloud to manage our renewable portfolio. We use AWS services like Greengrass for IoT, time series database, and we put our information into machine learning and AI models that can help us optimize the performance of our renewable portfolio. So let me show you what that looks like in real time here. So on the screen, you're looking at a heat map that represents 13 turbines over a 2-day period. So each row is a different wind turbine at the same wind project. And then the x-axis is 48 hours of time. And the color is the amount of power output that these turbines are putting on the grid. So you can see the dark red is high power output, so the day starts with a pretty windy environment, and it kind of tails off towards the end of day 2. And looking at this heat map, we can start to infer some patterns or trends. So the first one is that in turbine 2, the second row, and the bottom turbine, we see those turbines are down for maintenance. And that happens, that's part of operating a large wind project. But we want to make sure that turbines are going down for maintenance during non-windy hours, and that they're up and running and operational when the wind is blowing. So if this is a pattern or a trend, we can alert the operators to let them know that these turbines are down. We can even help them with things like predictive or preventative maintenance to make sure they're proactively maintaining their turbines when it's not windy so that they're up and running and can produce as much renewable energy as possible. Another trend we see is that most of these turbines are pretty correlated with one another. They're generating large amounts of power at the same time. But that correlation isn't exactly as strong for every turbine. And that could be part of a natural variation of a project. Turbine A is on this part of a ridge, turbine B is on a different part of a ridge, and they react differently to different wind speeds or wind directions. But it also could be because there's an equipment problem. There could be an issue with the gearbox in one of the wind turbines. And by looking at performance data over a long period of time, we can use these trends to see if anything's amiss, and then work with the operators to correct them. So already, we've been looking at this heat map for 30 seconds, and we can start to infer some patterns and trends in the data. But this is 13 turbines, and we have thousands in our portfolio. And we have tens of thousands of solar panels. And this is 48 hours of data, and we need to be looking at how these projects are operating every minute of every hour of the year. So it's large amounts of data. And it's just not scalable for us as an energy team to be looking at this information for all of our projects. So we use the software we built, we take this data, and we feed it into machine learning and AI models that can detect and infer the same patterns we just discussed in a much more scalable way. In total, we expect that we can increase the generation from our renewable portfolio, equivalent to adding a new 150 megawatt wind farm just by using optimizations like this. Okay, so we talked about how we're reducing carbon emissions from our electricity supply. But that's not the only source of carbon emissions for AWS's global infrastructure. We also have a source of carbon emissions known as indirect emissions. Those are emissions that we don't directly emit, but that are still impacted by our operations. And every business has these indirect emissions, and typically for most businesses, it means it's part of their supply chain. So we think about those indirect emissions in 2 big buckets for AWS. The first one is in the construction of our data centers. And concrete and steel represent the largest drivers of carbon inside our physical data centers. But we're taking initiatives to reduce the embodied carbon in those materials. So for example, our new standard designs in the US call for a new type of cement that is 20% less carbon intensive than the typical cement we use. In our US West region, our engineering, procurement, and construction teams have already identified suppliers that can provide this low carbon cement. And that's really important because companies like AWS and other companies that have net zero carbon goals are sending an important signal to the market that if they increase their manufacturing capacity of these low carbon materials, there'll be buyers for them. And we're doing the same thing in steel. So we identified that we can reduce the embodied carbon in steel if we move to new steel manufacturing techniques using electric arc furnaces and power those electric arc furnaces with 100% renewable energy. And it's just like cement. AWS goes out, we send a signal to steel mills and manufacturers that there's a market here for low carbon materials. The other major source of indirect emissions comes from our supply chain and the hardware that AWS procures. So there's two types of carbon emissions associated with our hardware. There's the use phase, and I talked about what we're doing to reduce carbon emissions from the use phase by increasing energy efficiency in our 100% renewable portfolio. But there's also the phase of embodied carbon, which is associated with manufacturing those pieces of equipment. So the embodied carbon associated with our servers and racks and hardware comes from everything from harvesting raw materials, processing and refining those raw materials in the manufacturing process. Silicon chips in particular can be complex to manufacture and pretty energy intensive. And the path to making our supply chain sustainable and reducing the carbon footprint is pretty similar to what we're doing inside AWS. And we're working with our suppliers to make sure that they're operating their factories and their supply chains as efficiently as possible, and that they're powering their factories with 100% renewable energy. So in addition to integrating sustainability with our infrastructure and operations, we also look for opportunities to link our sustainability programs with our community engagement programs. I recently got to visit one of Amazon's solar projects near Richmond, Virginia, with a group of high school students from Prince William County. And these students are interested in learning about careers in clean technology and renewable energy, and it's really fun to share one of Amazon's solar projects with them. So I'm going to share a really short video from that day visiting that solar project, and then Cornelia is going to join me on stage to talk about how AWS is working on community engagement. Amazon announced the Climate Pledge in 2019, which is our commitment to get to net zero carbon emissions by 2040. When we announced the Climate Pledge, we also made a commitment to power our operations with 100% renewable energy, and we're on a path to do that by 2025. AWS has a program called AWS in Communities, which is a community outreach program that leverages Amazon's scale and resources to have a positive benefit in the communities where we operate. So today we're working with Dominion Energy, who built and operates the solar project. We're hosting students from Freedom High School in Prince William County to share what we're doing in clean energy and to get kids excited about careers in renewable energy.
We were also looking to see if we could get students out of the classroom where they could actually make the connections. You can talk about solar energy and, I can sit there and lecture to you all about it, but you don't make those connections until you're actually on site and you get to see it in real life.
I've always been kind of like a fan of renewable energy, but I haven't really been able to dig deep into the science on solar panels by myself.
Not every student knows exactly what a career into wind or solar looks like, and solar and wind jobs are some of the fastest growing jobs in the country. I think a lot of students think to work in power you have to be an engineer or a scientist, and there's really lots of different ways to get involved.
I didn't know that the whole system, it all linked up to a computer, so you guys had to add firewalls, stuff like that, which is a career that I'm interested in, cybersecurity.
These are some committed, dedicated students who are very concerned and interested in sustainability and environmental stewardship.
This has opened my eyes up to definitely more careers in sustainability.
I learned more about how it was going to affect me and my life and just the future of humanity.
Good afternoon. I'm Cornelia Robinson, and I lead a program that's called Inclusion and Outreach for our data center community within AWS. And AWS in Communities is a part of Inclusion and Outreach. I'm really excited to be here to talk with you about just a little bit about what we're doing in the communities where we build and we operate our cloud infrastructure. Amazon Web Services is committed to making a positive difference around the world, whether it's using technology to solve the world's most complex issues, or it's leveraging the power and the enthusiasm and the passion of our employees who donate thousands of hours per year to make a positive impact in the community. We are dedicated to building a world where every person has the opportunity to live a life of dignity on a healthy planet. And so to make a positive impact in the communities where we build and operate our data centers, we established a program that's called AWS in Communities. AWS in Communities launches long-term innovative programs so that we can make that positive impact, and we can also engage our community members to make a positive impact with us. There are 4 pillars that anchor the work of AWS in Communities, and we try to make sure that everything we do ties back to those pillars. And so we start with the community first, and we learn about that particular community, and then we work backwards from the community's needs to establish the way in which we make an impact in the particular community. So the 4 pillars are STEAM education, equity, and access. And when I say STEAM, that's science, technology, engineering, the arts, and math, education, equity, and access. And then the second one is local technical upskilling. The third is environmental stewardship. And then finally, we have what we call take on a cause, which is employee engagement. And so again, to make a long-term impact in these communities, we try to make sure that we're anchoring all of our work back to one of those 4 areas. STEAM education, equity, and access. So what that entails is helping create the next generation of builders. And so just as you saw in the video, we try to help young learners make the connection between what they see and what they hear, and then seeing themselves reflected in the world of technology. Our efforts are aimed at providing equitable access to STEAM education and also making sure that we're providing opportunities and pathways for students. With local tech upskilling, we try to ensure that we're creating a community of individuals in all of our infrastructure regions around the world where they are ready when they start to work at AWS or in our data centers. We make sure that they have scholarships, that there are internships, and that there's a direct pathway into tech for the local community. With environmental stewardship, just as you saw in the video, AWS in Communities fully supports the sustainability goals that AWS has adopted. And so to support these broader sustainability efforts, we've partnered with a number of organizations, nonprofit organizations, as well as educational institutions that support our goals around sustainability. And then finally, our employees are 100% dedicated to making a positive impact in the places where we build and operate our cloud. AWS is dedicated to inspiring future builders, especially those from underrepresented communities and underserved communities who reside in the areas where we have a physical presence. And through our signature programs, which is our global programs, we try to make an impact at scale in all of our infrastructure regions around the world. As I mentioned, we focus on STEAM education as opposed to just STEM, because we believe that the arts help build future-ready students who develop into well-rounded and creative problem solvers. Our Think Big spaces provide a place beyond the standard classroom for students to explore and cultivate an interest in STEAM education and STEAM-related careers. And so these spaces encourage a hands-on, minds-on approach to learning. And so again, we're trying to make connections for these students so that they see themselves and they say, hey, if they can do that, we can do that too. We also have a program called AWS Girls Tech Day that's happening right now. And we launch these programs all around the world. And we aim to ensure that girls also see themselves reflected in technology and that we're decreasing the gender gap in technology. And then with our Cloud Room program, that's our newest signature program. We leverage the power and the excitement and then the enthusiasm of our volunteers, and they work with students from ages 9 to 14 to help ensure that they have pathways into tech. So I talked about our signature programs, and those are the programs where we're making a big, broad impact at scale, working with thousands of students at a time. We also have regional programs that we've established in partnership with some of our AWS partners. And so now I'm going to talk a little bit about those. For example, in South Africa, more than 17,000 students from underrepresented and underserved communities. They've gained key digital skills within 2 months using a smartphone app. And it's built by Tangible Africa and supported by Amazon Web Services. So with Rangers, an offline smartphone game app, it's challenging online players, or it's challenging the students who are using their phones to use a net to capture poachers. And so they're trying to save a rhino. So it's helping thousands of young people across South Africa learn problem solving and coding without even using a computer. And so it's developed by Tangible Africa and supported by AWS. This low-cost app helps children gain key skills in key digital skills in regions that don't have the kind of equipment or services traditionally used for teaching IT. The Rangers app addresses these obstacles, and it uses Android phones, and that's the most broadly adopted operating system across all of Africa with over 80% of the market share. The next program that I'm going to talk about is the Stepping Stones Alliance. So the Stepping Stones Alliance was established to address the increasing need for support services and shelter for community members in Eastern Oregon. The Alliance recently was awarded the bid for the City of Umatillo's Practical Assistance Through Transitional Housing Project, and we call that the PATH project. AWS and Communities is a proud sponsor of the Stepping Stones Alliance, with a recent donation of $100,000 for the PATH project. The project includes facilities, support services, and resources that will allow for the development of stable housing for those most in need. And Stepping Stones Alliance is working in partnership with the cities of Umatilla, Hermiston, Stanfield, and Echo, as well as the Umatilla County of Commissioners. And we're developing this project in collaboration with them to provide both emergency services as well as shelter services and transitional housing. And then as a part of our efforts in Hyderabad, one of our newest regions, we've started planting trees in schools and in communities around our Hyderabad sites. So far, over 10,000 trees have been planted to serve as biodiverse spaces. And the trees that are chosen for the planting are those that are native to the area and that formerly flourished around the area. And so our volunteers, our employees, they've already logged hundreds of hours towards this project. And then in Dublin, AWS is working with the South Dublin County Council to recycle heat from our data centers. AWS continues to support Ireland in meeting its 2030 renewable energy targets through the country, first custom-built sustainable solution to provide low-carbon heat to a growing Dublin suburb. The new district heating scheme in Tala, South Dublin, will provide heat recycled from the recently completed AWS data center to public sector, residential, and commercial customers. The system will initially heat 47,000 square meters of public sector buildings, and that's an area 3 times the size of the city's Croke Park, as well as 3,000 square meters of commercial space and 135 affordable rental units. And this is projected to save 1,500 tons of carbon per year during the first phase of the Tala district heating scheme. That's the equivalent of 60% reduction in carbon emissions. The South Dublin County Council has established Ireland's first publicly owned not-for-profit energy company as well. And then they've commissioned Fortum, an experienced Finnish energy supply company, to carry out the design, installation, and operation of the scheme. AWS will provide the recycled heat free of charge to the scheme, and then combined with additional heat pump technology, it'll be sold on to end users at a low cost by the district heating company that's trading as HeatWorks. So there are a number of sustainability breakout sessions that are happening. Hopefully you will all participate in a number of those other sessions throughout the week. And thank you so much for participating in this session. Charlie and I both look forward to connecting with each of you. Please don't forget to fill out your survey and let us know what you thought about the session. Thank you so much.